Today we will be learning about electronegativity.
Electronegativity is the measure of the ability of an atom in a chemical compound to attract its electrons. So basically, how strong the draw on the atom's electrons is.
Fluorine, having an electronegativity measure of 4.0, is the most electronegative element on the periodic table. Therefore, all other measures are made relative to fluorine's measure.
Electronegativity is measured using the Pauling scale. The scale was made by a famous American chemist named Linus Pauling. The Pauling scale uses numerical values ranging from 0.7 to 4.0, reflecting the tendency of an atom to attract electrons.
Now we will learn about trends.
Periodic trends. Electronegatives tend to increase across each period. There are exceptions. Alkali and alkaline earth metals are least electronegative. Nitrogen, oxygen, and halogens are the most electronegative.
Because more energy levels are created as you go down the periodic table, the atom becomes bigger. Smaller atoms have fewer energy levels that are closer to the nucleus and have a stronger pull on atoms.
Electronegatives tend to either decrease down a group or remain about the same. Noble gases, some of them, do not form compounds, so they do not have electronegativity. If a noble gas does form a compound, electronegativity is high.
Diagonally from the bottom left to the top right, elements are more electronegative. From the bottom left, francium is the least electronegative element on the periodic table. Moving diagonally up increases the electronegativity up to fluorine, which we have already established as the most electronegative element.
Most noble gases, the group of elements on the far right side of the periodic table, are not given electronegative numbers because they are already stable. They have a full valence shell and don't need any more electrons. In addition, they don't usually form compounds.
Elements become more electronegative from left to right. This is because on the left side of the periodic table, elements have less valence electrons, and on the right, they have more valence electrons. Since the elements on the left have less valence electrons, it is easier for them to become stable by losing electrons. If the atom is on the right side of the table, it would rather gain a full outer shell. Here is an example with lithium and fluorine. Lithium has 3 electrons with only 1 valence electron. As a result, it does not want a full shell as much as fluorine. Fluorine has 7 valence electrons, requiring only 1 more to fill its outer shell. This results in a higher electronegativity for fluorine.